That is a square's definition. 4 right angles and 4 equal sides. Folks, if you mark it, then it is true. Okay? There's a square. But if I just leave it like that, that's not a square. Right now, that's just a quadrilateral. Okay? To make it a square, I have to show that all 4 sides are equal by putting the slash through them. And then I have to show that it has 4 right angles by putting the squares in each corner. Now, that's a square. So 4 right angles is a rectangle. Here's your drawing. Again, you would just mark those 4 right angles. Even though there are other things we can conclude, the definition is just 4 right angles. Parallelogram. In a parallelogram, both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. It looks like a rectangle most of the time. It looks like a rectangle that's kind of been slanted. Alright? That's how you draw it to differentiate it from a rectangle. So if I was going to draw this parallelogram, I would draw a set of parallel sides, and then I would draw another set of parallel sides. How do we mark something to show that it's parallel?
Arrows.
Little arrows. Okay, that is parallel to that. And with 2 arrows now, those sides are parallel as well. That is a parallelogram. Good job. A rhombus is a quadrilateral with 4 equal sides. What does it end up looking like? A tilted square. It looks like a square that the big bad wolf has just come and huffed and puffed and blown sideways. Okay? There's a rhombus. It's got 4 equal sides, so I need to mark them. And you might think, hey, maybe that's a square. Well, if you don't have those angles marked as 90 degrees, it's not a square, it's a rhombus. At least one pair of parallel sides. So for a trapezoid, all you have to have, are those parallel sides. What has to be true about the other sides? They just have to connect. They can connect in any way, as long as they're closed.
Can they be squiggly lines?
They can't be squiggly because remember, with a polygon, they have to be straight lines. Okay? They have to be straight. Good question, though. And to mark them parallel, there we put those arrows on there, and you're all set. There is a trapezoid. Isosceles trapezoid has 1 pair of parallel sides, just like a trapezoid. Keep doing that. But then, basically, these other 2 sides have to be equal because these base angles are equal. Okay, so 1 pair of parallel sides, and then base angles that are congruent, just like an isosceles triangle. It's like you had an isosceles triangle, and it got cut off on its way up to the vertex. Okay, that's an isosceles trapezoid. As a result of those base angles being equal in an isosceles trapezoid, these sides, those are always going to be congruent as well. Remember the isosceles triangle base angle theorem? Same thing. 2 consecutive pairs of congruent sides. Okay? 2 consecutive pairs of congruent sides is a kite. Consecutive and congruent, I'm going to go out of my little area here and show it like this. Those are congruent. That needs to connect. And those are congruent. Consecutive and congruent. Touching sides are congruent. Okay?